You think your engine is safe once it's warmed up? Think again. The most destructive force in your vehicle isn't one big event.
It's thermal shock, that constant grinding cycle of hot and cold. I've torn down over 5,000 engines.
And this invisible stress is what kills nearly half of them. It cracks metal, bakes plastic, and murders electronics.
From the inside out. Today, I'm counting down the 11 signs of this silent killer and showing you how to stop it.
Before you face a $20,000 repair. And the number one failure, the one that targets your car's brain, is something you can prevent.
In 60 seconds, stay with me for the full breakdown and the battle plan to fix it.
Number 11. The Stage 0 Cold Start Scuff. Ever just start your car and immediately drive off? That smooth takeoff is hiding a brutal secret.
Here's the thing. Your engine oil is thick as molasses when it's cold. It can take up to 30 seconds for oil pressure
to fully stabilize and reach the tight clearances of your bearings and camshafts. For that half minute, parts are running nearly dry.
It's like asking a sprinter to run a world record with no blood in their legs. According to SAE paper 2019-01-0551,
this is where invisible micro-wear happens. At first, it costs you nothing. Ignore it for a year, and you're looking at
a fun $200 bill for noisy lifters and scored cams. Keep doing it for 5 years, and it's a $5,000 bottom-end rebuild.
That's the price of 30 seconds of impatience. If this feels harmless, remember the most expensive damage starts with the smallest habits.
Hear that cold start rattle? Tell me your make and model in the comments.
Number 10. The Turbo Coking Shutdown. You've just had a spirited drive. Pulled into your driveway. You turn the key off.
Hear that? It's the sound of a $4,000 mistake. Here's the thing. Your turbocharger's bearings are cooled by engine oil.
When you shut down a hot engine instantly, that oil stops circulating. But the turbo, still glowing at hundreds of degrees,
cooks the stagnant oil left inside into carbon deposits, a gritty sludge called coking. I trust it when you can smell it.
That faint, sharp, burnt oil smell is a warning. Most manufacturer guidelines recommend a 60-second idle to let things cool gracefully.
Ignore it, and you're looking at a $500 bearing replacement if you're lucky. Wait too long, and it's a $4,000 turbo replacement.
And if that seized turbo sends metal shavings into your engine, you've just bought yourself a $9,000 motor.
3 weeks later, that tiny bit of sludge has starved the bearings completely. Tap the like button if you're adding this cool down to your routine right now. Number 9. The manifold's ticking time bomb. Hear a faint ticking noise when your engine is cold that vanishes as it warms up?
You might think it's a lifter. It could be something much worse. Here's the thing. Your cast iron exhaust manifold
endures the most extreme temperature swings on the vehicle, from 60 degrees to over 1,000 in seconds.
Each cycle creates immense stress, causing hairline cracks. You can often see them with a flashlight. Faint, dark lines
against the rusty surface. General Motors TSB 06-06-04033F specifically addresses this, linking cracked manifolds to exhaust leaks.
An early catch is a $900 manifold replacement. Ignore the tick, and you could be replacing melted O2 sensor wiring.
And catalytic converters for over $3,000. Let hot exhaust leak onto a plastic wire loom.
That's how underhood fires start, and that's a total loss. Meanwhile, in Arizona, where temperature swings are extreme,
I've seen these split wide open on trucks with less than 80,000 miles. Don't guess. Grab a light and check yours.
Number 8. The radiator's chalky goodbye. Ever catch a faint, sweet smell of coolant after a drive, but see no puddle?
On the ground, you're smelling a slow-motion failure. Here's the thing. Modern radiators crimp plastic end tanks onto an aluminum core.
Plastic and aluminum expand and contract at very different rates. Over thousands of heat cycles, The gasket between them hardens and loses.
Its seal. This creates a tiny weep, a leak so slow it evaporates, leaving behind a chalky, colored residue where plastic
Meets metal. Data from the AERA Engine Builders Association shows these radiator seams are a primary failure point on vehicles over
5 years old. A new radiator is about $700 installed. Let that weep become a sudden split on the highway,
and you're facing a $3,500 bill for a new head gasket. If you don't shut it down in time,
you've just seized the engine for $10,000. Before you turn the key tomorrow, take a look for that residue.
That sweet smell isn't a feature. Find the source. Number 7. The post-drive pressure cooker. You park your car after a hot summer drive, but under the hood, the temperature is still climbing.
This is heat soak, and it's boiling your fuel alive. Here's the thing, with the engine off, there's no airflow.
Radiant heat can raise underhood temperatures by another 50 degrees, causing fuel in the lines to vaporize.
This builds pressure that stresses seals and the entire evap system. It can even cause vapor lock, where the engine struggles to restart when hot.
NHTSA Recall 18V567 for certain GM vehicles documents fuel pump flanges cracking from these exact pressure cycles.
A failing evap canister might cost $400. A cracked fuel pump flange is a $1,200 repair.
And the ultimate cost of pressurized fuel vapor finding a spark? A vehicle fire and a total loss.
I trust it when you can smell it. That strong gasoline odor is a direct warning.
If this feels harmless, know this pressure ages every rubber seal under your hood twice as fast.
Hit subscribe if you're tired of shops guessing at the problem.
Number 6. The brake rotor's blue scar. Look at your brake rotors. See any blue or dark brown spots?
That's not just discoloration. It's a permanent scar burned into the metal. Here's the thing. During a hard stop,
your rotors can exceed 1300 degrees Fahrenheit. At that temperature, the cast iron's microstructure changes, forming brittle spots.
Of a material called cementite. These spots don't wear evenly, causing brake pedal pulsation you can feel in your foot.
Brake industry technical papers from groups like Ray Bestos extensively document how these spots become the starting point for microcracks.
New pads and rotors might cost you $800, but those hard spots reduce your braking effectiveness when you need it most.
And the cost of even a minor fender bender from increased stopping distance? Easily $2,000 in bodywork.
3 weeks later, what started as a vibration becomes a real safety hazard. Is this happening to your car? Tell me in the comments.
Number 5. The rotor's silent fracture. Those heat spots we just talked about? They are ticking time bombs. Here's the thing.
The brittle cementite areas no longer expand and contract at the same rate as the surrounding metal.
Every time you brake hard, immense stress builds along the border of these heat spots, creating tiny, invisible microcracks.
Over time, they connect and grow. I've seen rotors on heavy-duty trucks that have completely fractured after repeated high heat cycles,
causing a complete loss of braking on that wheel. The first cost is the $800 rotor job you should have done earlier.
The next cost is the tow truck and bodywork from the accident. The final cost, that's the one that can't be measured in dollars.
Your brakes are your last line of defense. Meanwhile, in the mountains of Colorado, a driver relying on engine braking alone isn't enough.
Your life depends on these parts. Treat them that way.
Number 4. The wire harness's brittle skin. Ever have an electrical gremlin that just comes and goes? A flickering light.
Or a sensor that works one day and not the next. The problem might be the wire itself.
Here's the thing. The plastic insulation on your engine's wiring harness is constantly baked by heat.
Over years of thermal cycling, the plasticizers, the chemicals that keep it flexible, evaporate. The insulation becomes hard and brittle.
The slightest vibration can then cause it to crack, exposing the copper wire underneath. A huge number of electrical faults.
On vehicles over 10 years old stem from this. It's a nightmare to diagnose, often costing $500 in labor.
Just to find the one cracked wire. And that's just to find the problem, not fix it.
Before you turn the key tomorrow, understand that brittle wiring is one pothole away from a short circuit.
This is where simple fixes end and catastrophic failures begin. Number 3. The electrical ghost in the machine.
So that insulation has cracked. What happens next is a cascade failure. Here's the thing. Once that copper wire is exposed, it's vulnerable to moisture.
A single drop of water can create a short circuit, blowing a fuse or frying a sensor.
Or two adjacent cracked wires can touch, sending voltage where it doesn't belong. This is what sends a transmission into limp mode.
Or kills the engine instantly. I saw a 2010 F-150 that spent 3 months in a shop, all because of one cracked wire.
Behind the engine that only shorted when it rained. A new engine harness can cost over $2,500.
But if that short circuit fries a transmission control module or the main ECU, you've just added another $2,000 to the bill.
If this feels like a rare problem, know that every car on the road is slowly moving toward this failure point.
It's not if, but when. Number 2, the ECU's clogged arteries. Your car's engine control unit, or ECU, is its brain.
It lives in a metal box, often bolted to the firewall, and it gets hot. Here's the thing.
While automotive ECUs are rugged, their processors generate heat, and prolonged thermal cycling degrades the delicate solder joints inside.
Their metal case acts as a heat sink. Over years, that case gets covered in a layer of grime, insulating it.
And trapping heat. Electronics reliability studies from the U.S. military show that for every 10 degrees Celsius rise in operating temperature,
the lifespan of electronics is cut in half. An intermittent stall might cost you $800 in diagnostics before a tech suspects the ECU.
But once it fails, a new unit is easily $500 for the part, plus hundreds for programming. And this is just the warning shot.
3 weeks later, an intermittent stall becomes a no-start condition. Protect your car's brain. It's the one part you can't live without.
Number 1, the solder joint checkmate. This is the final move thermal shock makes to total your vehicle.
Here's the thing. That trapped heat, combined with thousands of hot-cold cycles, causes microscopic cracks in the solder.
At first, the connection is intermittent. The car might stall randomly, then restart. You'll get phantom check engine lights.
Then one day the connection breaks for good. The ECU is bricked. The car will not start. It will not communicate with a scan tool.
It is a multi-thousand-pound paperweight. I saw this on a 2008 Lexus that chased a stalling issue for a year.
The final bill for a new ECU and programming was over $3,000.
On an older car, that single repair is enough to send it to the scrap yard. This is the ultimate cost of unchecked thermal cycling.
Now that you know the enemy, stay right here, because I'm giving you the battle plan to fight back. Don't go anywhere. These rituals are next.
Now, let's turn warnings into action. Here are the 8 essential rituals to win this fight. First, the Stage 0 warm-up.
Every cold start, let it idle for 30 seconds. Watch the tachometer settle. That's your signal that oil pressure is stable.
Second, the turbo cool down. If you have a turbo, the last 60 seconds of every trip is a gentle cool down idle. No exceptions.
Third, the manifold flashlight check. Once a month, engine cold, shine a bright light on your exhaust manifold. Look for those hairline cracks.
Fourth, the radiator weep watch. Every time you check your oil, scan the seam where the plastic end tanks meet the aluminum core.
For that chalky residue. Fifth, the post-drive sniff. When you park a hot car, smell for gas or coolant.
Your nose is one of the best diagnostic tools you own. Sixth, the brake read. After a long downhill drive, look at your rotors.
If you see deep bluing, you're stressing them. Use more engine braking. 7th, the harness inspection. During maintenance, gently feel an accessible wiring loom.
If it feels hard and brittle, you know the clock is ticking. And finally, the ECU dust-off. Once a year, locate your ECU.
And finally, the ECU dust-off. Once a year, locate your ECU.
Use compressed air to blow the dust and grime off its case. Keeping it clean helps it live longer.
8 simple, free steps. That's the difference between a car that lasts a lifetime and one that dies a premature death.
From 1,000 tiny cuts, thermal shock is relentless. But now, you are prepared.
Now that you know how thermal shock cracks metal and kills electronics, the next step is understanding the chemistry inside your cooling system.
That coolant does more than manage heat. It stops corrosion that can destroy your engine.
Watch our cooling system deep dive next to catch the other silent killer that costs owners thousands.